Hello, I'm Orith, Assistant Professor of Gargi Memorial Institute of Technology. In today's lecture, we're starting a new chapter. The name of the chapter is laser. Now, what is laser? Laser is light amplification by stimulated emission of radiation. L come from light, A come from amplification, S come from stimulated, E come from emission, R come from radiation. So in a total, in a name, it is known as laser. So what is laser? We all already see that what is laser. Laser is nothing but one type of light. So what is the difference between the ordinary light and the laser beam? Okay, first of all, we have to know that what is characteristics of this laser. Of laser, monochromatic, TCT, intensity, coherence, directionality. Okay, so what is mean by that such type of characteristics? First is monochromacity. Monochromacity. Okay, so monochromacity says that the several physical account of for a departure from a perfect monochromatic light emitted from the source. That means we all know that the origin of the light is nothing but a transition of electron from one orbit to another orbit. What type of transition? We all know that the electrons revolving in a specific orbit. When the electron jumps to its initial orbit to any higher orbit, again for the unstability, this excited electron again returns to its that excited electron is again returned to its initial orbit, and when that electrons return to its initial orbit, that electrons release the extra energy gotten from the outside or for the transition from one state to another state. And such type of energy, sometimes it is visible ray, sometimes it is X-ray, sometimes it is ultraviolet, sometimes it is ultraviolet, sometimes it is infrared. Okay, so the transition of electron from any higher orbit, this is the first orbit, second orbit, third orbit, any higher orbit to the second orbit from 4 to 2, such type of releasing energy or the frequency lies between the visible ray. So that means the visible ray, the origin of the visible ray or light wave is responsible for the transition of the electron from any higher orbit to the second orbit. Okay, so first characteristics is known as monochromacity. So monochromacity says that in a laser beam we only can see the one wavelength. That means the transition of electron will be happen between the single orbit, not for the all higher orbit to the second orbit. It transits from the any single orbit from greater than 2 to second orbit. So that's mean in the laser beam we just see the just one wavelength. That's why the monochromacity is coming, the monochromatic light. The intensity the intensity, if you compare with the laser beam with with ordinary light, you can see that the laser intensity, the intensity of the laser beam is much higher than the ordinary light. So if you compare, the 1 watt laser beam intensity is much higher than the 10 watt ordinary beam. How it is possible? We just, laser beam is focused by a lens. The tremendous intensity at the focal point, we just suppose this is a source, we put a lens is here, so that means the every light is concentrated in a one point. That means the intensity of the light is concentrated in a some one point or a one area, small area. That's why the intensity of the such light or a laser beam is much higher than the ordinary beam. Okay, and the third point is coherence. Coherence says that the laser radiation is the characteristics by a high degree of coherence. That means high degree of ordering of light field compared to other source. So that means the reflection, if you reflect this light from one surface through the one surface, the total intensity, the maximum intensity of the light is reflected by that surface, and such type of characteristics is known as coherence. Okay, and the directionality said that there is no bending of light, no diverging of light. The light always travel in a one direction. Okay, this is the another characteristics of the laser beam. Now we study about the how the laser beam is generated, how it is work. How it is work. It is nothing but a transition of electron. The transition of electron from one orbit to on another orbit is happened by the three process. One is called stimulated absorption. Second one is spontaneous emission, and third one is stimulated emission. Okay, so now what is the first one we are explain here is stimulated absorption. Stimulated absorption, how it is possible? Suppose this is one of the orbit have a energy E1. This is the another orbit have a energy 2, or a energy state 1 or a energy state 2, where E2 is greater than E1. E2 is a higher energy state, E1 is a lower energy state. Now stimulated absorption. Stimulate means you put the energy from the outside. Okay, stimulated, you put some reactive force from the outside. That means the stimulated word is coming. It is not happen between itself by the atom or the electrons it is done by the electron itself. It is electron done by when you put some energy, or anyone put some energy from the outside, then the electron get excited. Suppose the one electrons now rotating stable in a energy state 1, or suppose in a one orbit. Suppose it is a second orbit of the atom. Now you put some energy or a wave energy to this medium. Okay, now due to when this energy is flowing through this medium, the electron gets some energy from this wave. Okay, when this electron gets some wave, it is become excited and going to the upper state of the material. That means E2, E1, it is coming over here. So that means through this process there is no emission of light. There is only through this process the energy of the h nu is getting by this electron, and this electron is now excited and it is jumped to the lower orbit to the higher orbit, just absorb this energy, and such type of process is known as stimulated absorption. That means stimulated in the external process we gave some energy from the external wise, and that internal electron gets that total energy and jump to the higher orbit and observe the total energy, and that process is known as stimulated absorption. Is it clear? So we can written here that an atom is ground stated with, in later we can write out here, with energy E1 absorb a photon. Obviously we put some light energy, and light energy have a photon. Light have a photon particle of energy h nu and goes to the excited state, and such type of process is known as stimulated absorption. Okay, so this is stimulated absorption. Now I think what is stimulated absorption, it is clear for everyone. Now the second process is spontaneous emission. So in that case we can see that there is a spontaneous emission. The electron, what will be electron is done, it is done by itself. No other external force is happen in that case of the spontaneous emission. As well as the emission word says that something is emitted through this material. Something is coming from the material after this process is completed. Okay, so that means suppose one electron E2, similar thing, E1 is the ground state and E2 is the higher state. Suppose that one electron is in a higher state. Okay, through the process, some process will happen with that electron. Suppose stimulated absorption is happened in a previous few times ago. Okay, then the electrons now is in a higher order state. For when the electrons live in a state in a higher order state, that electron is already excited. The electron have a much more energy than the equilibrium. Obviously the electron need to be coming to the equilibrium position. So that's why electrons return to its lower energy state. This electron return to its lower energy state. When the electron return to its lower energy state, the electrons release the extra energy the electron have, and this energy is coming over by to the in form of photon or in form of light, and this process is known as spontaneous emission. Huh? So that means, what is spontaneous emission? The one electron already is in a excited state. Due to the instability, that excited electron return to the lower energy state for the stability. When that excited electron return to the lower energy state for the stability, these high energy electrons release the extra electrons these electrons have, and this energy is coming over in form of light or photon, and such type of process is known as spontaneous emission. Now in later we can write here, atom in the excited state will not stay for a long time, so the atom in, so with the high energy, the atom or the electrons so the atom in excited state E2 returns to the ground state E1 by emitting a photon with energy h nu, and the value of the h nu is always E2 minus E1, and such this phenomena is known as spontaneous emission. Is it clear for everyone? Okay. Now the third process is stimulated emission. Okay, so in the first term we can see that the stimulated was what is also coming in the first place. Okay, that means stimulated, that means we put some force from the outside, and it also not only absorb, it release some energy through the material. That means we put some energy, and after the processing, this process, the material release some energy, and that process is known as stimulated emission. Now let's see what will happen. Suppose one excited electrons already is in a excited state. Again, the electrons the electrons or atoms already is in a excited state. Now you put some energy from the outside. Now what will happen? Due to the instability, for the stability, this electrons return to the ground state energy level. So that means one h nu is coming from the transition of electron, and another wave is coming when you put from the outside due to for the stimulated process. So that means 2 h nu is coming. That means the energy or the intensity of this process is much higher than the spontaneous emission. So this process is known as stimulated emission. That means if an atom in excited state interacts with a photon that photon triggers the excited atom to make the transition, and we make the transition, so we can get the and another thing is that when this photon triggering this electron, that means the frequency of the that's why this frequency triggering this electron from coming to the excited states to the ground state, that means the release energy for the transition of this electron from higher state to lower state, the frequency is also equal. That means the phase between this wave is very negligible. That means the frequency almost equal or the phase is almost same. So that means the intensity of this light is much higher than the ordinary any type of emission, and such type of process is known as stimulated emission. So today we are studying what is laser, how laser beam is occurs, and how we study about the three process of the laser. In the next classes we know about the another term is known as another few terms, population inversion, pumping, etc. Okay, today's for the end. Thank you.